Welcome to all. On behalf of Department of Statistics, Dr. B.R. Ambedkar Open University.
Today we are conducting a telephone program conference on normal distribution. Today with us two professors. One is Professor K.Sampah Kumar, HOD and Dean Faculty of Science, Telangana University, Nizamabad. Another professor is Professor N. Raju, HOD and Professor Gurunanak Institutional Technical Campus, Hyderabad. Today we are going to explain what is the importance of normal distribution, what are the applications of normal distribution, what is the real life applications of normal distribution. So now I am going to hand over the first Professor Dr. Sampah sir.
Today we are discussing normal distribution. This is very important distribution in statistics. Without normal distribution, I think there is no statistics. The statistics importance is increasing day by day. Because the statistics actually the mathematical formula is established by D. Movier in 1733 and afterwards Gaussian distribution name has come by the Carl Friedrich Gauss. So the normal distribution function is mainly symmetric distribution. This is almost all similar to bell shape. This normal distribution applied to different estimation theory and different type of calculations in statistics and forecasting.
So what is the actual difference between discrete and continuous probability distribution? I think it is a continuous probability distribution.
Yes, normal distribution is a continuous distribution. This is actually for example, we can take the heights of some persons. This is a values, numerical values continuously we can show. It is continuous distribution means when we construct a curve, it is continuous form of the curve.
Yes sir. In previously students are studied discrete probability distribution like binomial and Poisson distribution. In normal distribution also is a limiting case of binomial distribution as n tends to very large and neither PR nor QR very small. Then Professor Raju sir, please explain in detail what are the normal distribution statistical parameters with applications.
Thank you Ramesh, Dr. Ramesh. So today we are, so eminent person Dr. Sampah sir said what he said is exactly, the distribution was very important distribution. Today we are taking the normal distribution in any field. Every field is having the most important fundamentals. These fundamentals are very related to this normal distribution because we can apply the normal distribution properties wherever it is required. So today normal distribution is one of the important probability distribution in statistical analysis. Whichever field is there, either nowadays even though machine learning and data science, other parameters, even science, social science, physical science, wherever it is required, this normal distribution applications we can use in our daily life also. That is the most important thing in statistical analysis. Now, normal distribution. So, what is a normal distribution actually? So, now I am going to define the normal distribution. The definition of normal distribution. So, normal distribution is one of the continuous distribution. Okay.
Yes.
So, in terms of normal distribution, in terms of continuous property, continuous distribution, we define the normal distribution. What is the normal distribution actually? A continuous random variable x is said to have a normal distribution with parameters mu and sigma square. If its probability density function, simply it is represented by PDF, is given by f of x is equal to 1 by sigma into root over 2 into pi into e to the power of minus 1 by 2 of x minus mu by sigma whole square. This is the probability density function of the normal distribution. Okay. If we can say any distribution is said to be normal distribution, generally we should satisfy the two properties, especially one is, first property is first condition, that is known as a condition. Moreover, before define the normal distribution, we define the parameter range also. So, x lies between minus infinity to plus infinity, mu, one is a parameter mu is also lies between minus infinity to plus infinity. That is why we are saying this is a continuous distribution. And standard deviation and variance sigma square is greater than or equal to greater than 0.
Never be negative, always
Yeah,
zero.
always these are positive. So here we have observed the two parameters here, one is pi, another one is e. So these two are constants. Okay, so we know that pi value is equal to 3.14159. This is the pi value,
That is a mathematical
constant. These are the constant. The constant value pi is equal to this one, and moreover that exponential value u is equal to 2.71828. Okay, now what I said earlier also, then this function is bell shaped. So Dr. Sampasari said, so normal distribution is behave like a bell shaped. Okay, why it's a bell shaped? So this is a bell shaped curve with different centers and spreads, depends on two parameters, one is mu, another one is sigma. Based on these two parameters, this normal distribution behave like a bell shaped curve. Okay, so moreover, before that, one more we have to need to check, so whether the given function is already said probability density function. For that, we need to check two conditions. One is probability of, that means p of x function is greater than or equal to 0. Second one is integral, total integral value, that means minus infinity to plus infinity f of x dx value is equal to 1, then x ranging from minus infinity to plus infinity and mu ranging from minus infinity to plus infinity, and sigma square is greater than 0. Generally this normal distribution is represented by one notation. Okay, if x follows normal distribution with the parameters, already we know that mu and sigma square are two parameters. Okay, so mean and variance,
two parameters.
Then two parameters, mean and variance. So then mathematically we can write x follows n of mu comma sigma. What instance n is a normal distribution. So this is the definition of normal distribution. Now I am hand over to Dr. Sampath Kumar sir. He will explain about moment generating function and other that properties.
Yeah, generally when we study the normal distribution, most of the properties we can discuss on normal distribution. In that, one of the thing is moment generating function. So we can take the moment generating function. Generally we can calculate the moment generating function for discrete distributions and at the same time continuous distributions. For particularly if we go for the normal distribution, we can take the moment generating function equal to expectation of e to the power of tx. So that means we can just simply we can say integration of minus infinity to infinity e to the power of tx fx dx. So here fx is the normal distribution function. After simplifying this, we can able to get the moment generating function as e to the power of mu t plus 1 by 2 sigma square t square. This is a moment generating function. Using this also we can extract the different type of moments also. First we can take the first moment is differentiation with respect to t of moment generating function of the normal distribution. After t equal to 0, we will get the mean value. At the same time, we simultaneously we will get the, if you take the double differentiation and t equal to 0, we will get the variance using a principle mu 2 equal to mu 2 prime minus mu 1 prime square. So that is sigma square. Next we can go for the mean and variance of normal distribution. So mean equal to expectation f x, that is equal to minus infinity to integration of minus infinity to infinity x of fx dx. So we will get the value is mu. At the same time, mu 2 prime equal to expectation of x square, and we will equal to integration of minus infinity to infinity x square fx, that is equal to mu 2 prime. After getting this mu 2 prime, we can able to get the mu 2 value, that is variance. So, and there are the standard deviation also there, that is equal to square root of the variance, that is sigma is standard deviation.
Yes. In general method is there, you can derive mean e of x square. Yes. Before that general method, already go for generating function. Is the one of the simplest method to derive the mean and variance.
Not only mean and variance, sir, we will get the higher order moments also using the moment generating function.
Yeah, exactly what Sampath Sari said. A student can remember these important things. One is, so mean, and always a student can remember what is the normal distribution mean value, just now how to derive the mean and variance of the distribution. So just now sorry said explain about moment generating function, making use of moment generate mean and variance. Okay, so what is the mean here? Mean is generally we can represent it, mean is equal to mu and variance is equal to sigma square. A student can remember these two things because based on these two parameters this entire distribution will be described in detail.
Right. Yes. Now we can discuss the characteristic function of the normal distribution. The similar what we have calculated the moment generating function, similarly we can calculate the characteristic function of normal distribution using the principal expectation of e to the power of itx, that is equal to integration of minus infinity to infinity e to the power of itx fx to dx. Here fx is the normal distribution. Based on that we can generate the characteristic function as mu e to the power of I mu t plus minus 1 by 2 sigma square t square as the characteristic function of the normal distribution. On similar how we can calculate the moments of using moment generating function, on similar way we can able to calculate the moments from the characteristic function also.
Okay, sir. Okay, sir.
So simply sorry said that is a characteristic moment generating function as a characteristic equation. Both are similar, but only thing is instead of e to the power of it, e to the power of itx, then you write complementary value here.
Yes.
Yes, that is only difference.
What is the purpose of characteristic function? Already we have generating function is there.
Yes.
Why you are go for characteristic functions?
So then
please
means we have to
explain.
check the skewness and curtices and their first order, higher order moments. We need to find out the higher order moments. We will get the accuracy results.
Yes. Sometimes maybe generating function not exist.
Then
go for characteristic function.
That is will provide the exact solution, exact curve nature. Based on that our orders will decide the nature of the function. We'll check the data fitting natures.
Yes. Not only normal distribution, any distribution we can using this characteristic function we can able to find the different properties using these functions.
Yes.
At the same time beta 1 equal to 0 and beta 2 equal to 3, this is only for the normal distribution. For other distributions the values may be differ based on the characteristic function, and we can able to calculate the higher order moments. We can calculate this beta 1 equal to 0, beta 2 equal to 3. This represents the symmetry of the particular distribution. For particularly if we go for the normal distribution, the odd order moments should be 0. Because the symmetricity of the symmetricity character, the all odd order moments should be 0.
So all order moments means 0.
So Professor Raju sir, what is the meaning of beta 1 equals 0 and beta 2 equals 3?
So that means
beta 1 is 0.
Yes.
How to interpret it that students or understanding the
so
purpose
that means
of
the nature of the curve will identify if it is skewed. So origin to with reference to x-axis how the curve is behave. So we should estimate if the beta 1 is equal to 0 and beta 2 is equal to 0, then only we will get bell shape.
So based on
whenever the bell shape curve is there, the 99% of data will be considered in that any data statistical analysis. Okay, so that is one of the things. So that is one of the beauty of this normal distribution, because only one distribution is having beta is equal to 0, beta 1 is equal to 0, and another one is beta 2 is equal to 3. So no distribution, another distributions don't have this type of behaviors.
That is why normal distribution is a bell-shaped curve or mesocurtic curve.
And we can say the father of the distributions, because this much of importance is there in the statistics. So we can say father
not only
of the
even though this psychology, in the psychology behavior of the student studies also based on this how. So whenever we conduct the exams, we distribute our question paper BTL levels behave like a normal curve, probability curve, then only that BTL level be satisfied. So nowadays we are NEP 2020 tells about outcome based education system. How we fitted this data, how your question paper will be designed. Based on that question paper numbers and BTL level, we can construct the normal curve. If you will get the normal curve, your question paper should be moderate and it will be satisfy the conditions of the normal distribution. Even though marked distributions also. That is a psychology. Then psychological point of view. Now,
what another properties of normal distribution? Please explain, Professor K.Sampah sir.
Next we can discuss about the even order moments, sir. That is we can say simply even order means 2n, mu of 2n equal to 1 into 3 into 5 into 2n plus 1 into sigma to the power of 2n. N is 0 to 1 to 3. So these even order moments also we can directly calculate when we know the standard deviation or variance values.
Yes, sir.
Okay, directly we can get the higher order moments. At the same time, we already discussed that odd order moments are 0. And next we can go for the linear combination of independent normal variates. Generally, any independent normal variates, we can go for some differentiation. The following distribution should be the normal distribution only. Example, if x follows the normal distribution with mu1 and sigma 1 square, and y follows the normal distribution with mu2 and sigma 2 square, then x plus y follows the normal distribution of mu1 plus mu2 and sigma 1 square plus sigma 2 square. That means the sum of the normal variates should follow the normal distribution. So, even though if you take the linear combination of those things, it will follow the normal distribution only.
Yes, sir.
In a normal distribution also, we can able to calculate the quartile deviation, mean deviation and standard deviation also. So, this is a very important concept in normal distribution. We can able to define the ratio of these three components, that is quartile deviation and mean deviation and standard deviation. This should be range as 10:12:13.
Yes.
So, this is very important concept in normal distribution also.
Yes.
The mean deviation is 4 by pi sigma.
4 by 5
4
of the
by
standard
6.
deviation.
With its
QD is 2 by 3 sigma.
Yes.
Right.
Standard deviation is sigma. When
Yes,
our
right,
ratio we calculate, that is 10:12:15.
Yes,
Right,
exactly,
right,
exactly.
exactly.
Here, quartile deviation, mean deviation, and
The standard deviation.
These three parameters are vital play the vital role in while calculating estimation of the parameters.
Next, the maximum ordinate lies at the mean value. That is actually where the curve, bell-shaped curve, maximum elevation is there. That is, we can say that is at the point of mu. That is mean. At the mean point, the ordinate will come. That is x equal to mu.
At x equal to mu, that value is 1 by root 2 pi sigma.
Yes,
That is why
exactly.
curve should be always maximum at occur at x equal to mu.
that is, we can say single peak only.
Yes,
That
yes.
means
Single peak.
Yeah, that is unimodal curve.
Unimodal
We can
number.
say here.
Yes, sir.
If there are two tails, whatever extended infinitely and never touch the horizontal line, that is x-axis line, the curve should not touch any time, because we have taken the minus into infinity x range, the curve will not touch the horizontal line. The mathematical equation is completely determined if mu and sigma are known only.
Yes,
Okay.
exactly.
And very important property for normal distribution is mean equal to median equal to mode in this particular distribution, because when we define the mode of this one, wherever the maximum value of fx, we can define that particular x value should be the mode. At the same time, the curve should be equally divided. We can say wherever the x value divides the curve into two equal parts, we can say that is mode. When these three calculations, when we look into the normal curve, these three characters are equal at x equal to mu only. So, that means mean equal to median equal to mode for particularly normal distribution.
Yes, sir. Yes, sir.
Yes,
Median
yes.
is divided
Yeah.
into two equal parts.
So that
given
is why
series.
Yes,
the
yes.
Mode is the maximum value of probability occurrence at x equal.
X equal to mu.
X is equal to mu, then automatically the transfer standard normal variate is converted to z is equal to 0, which
I
is
think this
divided
is the
into
only
two
one
equal
distribution,
parts.
sir. This is
equal
only one
to-
distribution, only mean equal, median equal mode.
Yes,
That is called as a
exactly.
symmetrical distribution.
Yes,
So,
yes.
thank you very much, sir. So, once again, thank you, sir, for your valuable and informative lecture.
Okay.
So, now I go to another professor, Raju sir.
Yeah.
What are the applications of normal distribution?
Yeah.
The further, that is what area property is the most important. So, please briefly explain the area property of normal distribution.
Okay, sir. So before that, just I will think about, say, just give the brief about once again what is the normal probability curve. Okay, with diagrammatic representation also in upcoming slides. Okay, the total area under the normal curve is equal to unity. Just now we discussed.
Yes.
Okay, total area probability is 1 only, that is z is equal to 0 if it is divided into two parts. That is why total area must and should be equal to 1. And presenting percentage of distribution of area under the normal curve is given below. Okay, about 68% of area fall between mu minus sigma, mu plus or minus sigma limits.
So we can say 1 sigma limits. We can
1
say
sigma
this.
limits
Right.
and 2 sigma limits, and we have a 3 sigma
sigma
limits.
right.
So 68% of data falls under 1 sigma limits.
That is mu plus or minus 1 sigma.
Mu plus or minus sigma.
Sigma.
And about the 95.5% of area falls between second sigma, 2 sigma limits, that is mu plus or minus 2 sigma. About 99.7% of area falls between 3 sigma limits, that is mu plus or minus 3 sigma.
Yes, for that purpose only, in general, we can use 6 sigma limits in quality control.
Yes,
also.
excuse
So
quality
now-
controlling.
Yes,
we will
yes.
get the 99.7 accuracy of whatever we test in quality control. In
yeah.
that, we are using the 6 sigma limits.
Yeah, whatever the things just now we discussed, just I have shown this picture, this is a bell shaped curve. So this is called as a percentage of distribution area under the normal curve. As what I said, this is 68.27% up to this is a 1 sigma limit. Now if I take the 90, so up to this point 2 sigma limits. Now if I take the entire data, this is 99.73%. This is the 3 sigma limits. I represent here mu minus sigma up to this part, and so now I said just this normal distribution is never touch our x-axis. I will see in this curve last horizontal curve.
Horizontal
So
line.
this is x-axis. This tails, this left tail and right tail never touch with our x-axis.
X-axis, right.
Yes.
Okay, so our range of the distribution is minus infinity to here minus infinity this side is plus infinity. We will get the maximum value. Where we get the maximum value here? Ordinate. This x is equal to mu. That is why this normal distribution behave symmetrical about mean, median, mode. Okay, so this is the curve. So total explanation depends on this curve. If you understand this curve, we can able to answer any type of questions given to in examination point of view also. Now, so uses of what is the use of normal distribution in general?
Yes, sir.
Okay. What Sampath Sari said in the beginning also, few already we are using the sampling distribution and other things, but in that normal distribution can be used approximate to the binomial distribution, because these two are the limiting case of the normal. Binomial distribution is a limiting case of normal distribution, as well as Poisson distribution is also limiting case of normal distribution. These are the two important approximations. Okay, so it has extensive use in sampling theory. What already one of the my professor is Sampath Sari said already, what is the use of sampling theory? Okay, so sigma limits. So sigma limits,
Quality
control point of view, use this normal distribution concept. Okay, next one is it helps to estimate parameter from statistic and find the confidence limits of the parameter. So this plays a vital role in the testing of hypothesis. Okay, so how to estimate the parameter? If you know the parameter and statistics, then only we should identify the confidence limits, level of
Confidence limits and data properties.
and other things.
Yes, yes.
Okay, it has a wide using in testing statistical hypothesis.
Yes.
Yeah, and test of significance, in which it is always assumed that population from which the sample have been drawn from should normal distribution or normal population.
Yes, sir.
So why normal population? So its data is sync with our normal distribution. That is why we are always consider this normal distribution. It has a significant applications in statistical quality control, as the control chart in statistical quality control is closely related to normal distribution. This is one of the important accept. Okay, now it serves as a guiding instrument in analysis and interpretation of any statistical data.
Example here is a regression analysis.
Yes,
Without normal property of the given data, we cannot go for the regression analysis. We may not get the proper results.
Yes,
because first we are supposed to check the data follows the normal distribution, then only we can go for the regression analysis. This is one of the important tool in statistics. Without a normal property, we cannot do this regression also.
Yes, exactly, sir. So just that is a modeling, forecasting modeling.
Yes,
So if
forecasting
you have to
modeling.
go for forecasting model, this normal distribution play the vital role.
Very important.
Yes.
Very important role, key role. Otherwise, we can't forecasting the nowadays. Many of the organization, they are forecasting the things, how they behave, what is the current trend, how the future. So estimation, this based on this normal properties. That is why this normal distribution play the vital role in the trend analysis or statistical analysis.
Yeah. Wherever we can apply the parametric analysis, anything in statistics, compulsory that data should follow the normal distribution.
Yes, sir, exactly,
Yes.
exactly.
Right.
So after that, we will go for one more important topic is that is fitting of normal distribution. Fitting a normal distribution or a normal curve. Okay, so normal curve is play the vital role because we need to study the nature of the curve. The purpose of fitting of the normal curve is twofold: to judge whether the normal curve is a good fit to the sample data. Another one is to use the smoothened normal curve instead of the regular curve representing the sample data is to estimate the characteristics of the population. Generally, we use the diagrammatic representation. Sometimes it is not affected to not get the correct idea about the distribution. In that case, we can go for this fitting model. Okay, fitting of a normal distribution case. Now, there are two methods finding the normal distributions. One is ordinate method, second one is area methods. So, ordinate method, the normal curve can be fitted by reference to a table of ordinates of the probability curve. Then coming to second method is area method. The normal curve can be fitted by reference to table of area of the probability curve. So, the total already we discussed, total area of the probability is 1 only. So, the total area under the normal curve is always 1. Okay. So, now how to find? So, what is a working procedure? A student can understand how to find the probability when the variates normally distributed. So, for that a student can understand, a student is able to understand this procedure. That is why I am going to explain step by step procedure.
So, these are very important for examination also.
Yeah, what Dr. Ramesh said is a very important point of view. Examination point of view also, working procedure is used. A student is understanding the working procedure, then he is able to apply this methods wherever it is applicable. Okay.
This is also very important in competitive examinations also, these methods. Most of the even general knowledge quantitative techniques questions also, some of the competitive exams also these type of questions are asking. So, this is very important topic for graduate students for learning how to calculate the probability values with the range.
Yes, sir. With now I am going to explain for student point of view, for a student understanding this concept. For that I am explaining the working procedure and few example problems for understanding of the student. So, working procedure for this normal distribution is, normal to distributed values is, okay, let x be a normal variate with mean mu and standard deviation sigma. Already these two mu and sigma are what? Two parameters
of normal distribution.
Parameters of the normal distribution. Suppose we want to find the probability that a randomly selected value x will be lies between a and b. Okay, in that case my probability, that is probability of a is less than x is less than b.
That is
okay, my
area,
values are
that is nothing but area between
these two particular a and b values. A and b values. For that, first step is convert x into standard normal variate by the formula z is equal to x minus mu by sigma.
That is called normal
standard normal variate.
That is exchange to z.
Standardization of the data.
Standardization of the data, because x data is a big data. That is converted into normal data. We need to find out the smaller values. Then by making use of table, we should identify the standard tables are available with us, standard normal area tables. By making use of that standard tables, we can compare with our z value. We find out the z values. After that, we need to check the what is the chance, what is the probability of that values lies between these particular related problems.
Yes, sir.
Yeah, that step number 2 is coming to find the limits of z corresponding to the limits of x. Okay, so when x is equal to a, standardized, my data is converted into standardized form. When x is equal to a, then z is equal to what? A minus mu by sigma. This mu a is a variable here. Mu and sigma are standard values. In our question already these are the parameters given to us. Okay, when x is equal to b, then z becomes b minus mu by sigma. Okay, these are after converting the z. These values I can substitute in step number 3. My step number 3 is probability of a is less than x is less than b. For that, we need to find the probability values. That means probability of a minus mu by sigma is less than x is less than b minus mu by sigma. That values a minus mu according to our question is what? When it is our data is transformed to in terms of standard normal variate. Na? First one I can assume z1, and let us assume the second value is assumed to be z2. My z values always lies between z1 and z2 only. After getting these z1 and z2 values, now from the table find the probability of Z lies between Z1 and Z2. So making use of table, we should find the what is the value, what are the required information is required. Based on this Z1, Z2 values, we will get the solution to this particular probability.
That means we will get the area between the
Yes.
Z1 and Z2 in standard normal tables.
Yes,
sir.
exactly. Now what I said just now, how area properties used in while discussing the problems. I am going to explain few example problems here. So application problems are normal distribution.
Right.
Yeah. First example problem is entry to Dr. B.R. Ambedkar Open University, Hyderabad is determined by a national level eligibility test. The scores in this test are normally distributed with mean of 500 and standard deviation of 100. Sai Pranati wants to be admitted in this university and she knows that she must score better than at least 70% of the students who took the test.
Okay.
Sai Pranati takes the test and scores 585. Will she be admitted in this university? This question is asking like this.
Yes.
So already we are tested, exam is conducted, we know the
Mean
Data.
mean and the data sets also we know that.
Yes,
Okay.
yes.
How so whether she will get the admission in Dr. B.R. Ambedkar Open University or not.
Okay.
Further, so this data I would like to convert. I can apply my normal standard normal variate procedure. For that, I need to find the probability. How much chance she will get to get the admission in this university.
Yes. We are giving the only chance, not exactly.
Not exactly. We are estimate forecasting.
Right.
Probability tells about chance only.
Chance only,
Okay.
right.
So let X be a random variable that represents the scores. The scores are distributed normally.
Normal distribution.
So that means X follows n of mu comma sigma. Okay. Yeah. So n is equal to what here? 500 and standard deviation is given. That is why I put here sigma. Standard deviation value is only given to us. Okay. So that is why you can, otherwise generally we can take
Sigma
mu comma
square.
sigma square.
Variance
But
is
in our question they given standard deviation only.
Yes.
So directly standard deviation given. That is why I use the symbol standard notation X follows n of mu comma sigma. So for that X follows n of 500 comma 100. The total area under normal curve represent the total number of students who took the national eligibility test.
Right.
So that means, so if we multiply these values of area under the curve by 100, we will obtain the percentage, generally this. Okay. Now, for our calculation point, what is the first step? My X value is transformed to Z. I know the formula. What is the formula? Standard formula. Z is equal to X minus mu by sigma. So my X value is 585. This score is substituted in Z. Z is equal to, in that case, Z is equal to what? 585 minus 500 by sigma. So after simplifying this value, so that means 85 by 100. Generally we will get 0.85.
Yes.
Okay. The proportion, that means P of students who scored below 585 is given by probability of area to the left of Z is equal to 0.85. How this I can explain the tabulated form also. So for that, from using the table I got this value. What is the using table from normal
standard
table?
normal tables.
Standard normal. I can. So a student is can able to identify this thing. How to identify this normal table value? I will explain one in making use of this table also in this example. Okay. From table, how I get this table I will show in next slide. Okay. What is the value here? We got it here 0.802.
So that person may get 80% chance for getting
Yeah.
that.
Yeah. Then how I will explain this thing in next slide. So now it looks like a which curve here? Bell shaped curve.
Right.
Z takes a values where to where here? Minus infinity to plus infinity. Z is equal to 0. My Z value is here falling under this side.
Right.
Here, this is my Z value. My Z value is equal to how much here? 0.85. Okay, now you see. So looking up the standard normal table. These are the tables. Now just you check it. What is the area to the left of Z is equal to 0.85 in the standard normal variate? That is a question mark.
Yes.
Okay. Now how student is identified? You check the here vertically we have to go for 0.8. after point we can consider first number,
First number.
first digit only. What is the first digit here? 0.85 here. Here, have you seen this in the, I can put a box form here. This. Now, my value is Z is equal to 0.8 is in vertical. Now I can go for horizontally.
0.5.
So now horizontally, what is the value? After not consider this, 0.85, 0.05 here in this table. This intersection point, that intersection point is tells about value. The table. This is a way of a student can able to identify the table value.
Yes.
So horizontally and vertically. So these are the vertical values up to 3 only, maximum value, because what is the maximum range here? 3 only, table. Yeah. So this side we have taken the whatever the values is required for us. The intersection point, horizontal and vertical value is intersection point is provided as to table value. So in that case our total table value is 0.8023. So I will get the total area, already just now I explained here, total area is equal to this percentage into 100.
Yes.
I got this total area is 80%. Okay, 80.23%. Okay, so this is the way of. Therefore, probability of area to the left of Z is equal to 0.85 is equal to 0.823 into 100% is equal to 80.23%.
Yes.
So now I can say, I can conclude, Sai Pranati scored better than 80%, 80.23% of the student who took the national level eligibility test, and she will be admitted in the Dr. B.R. Ambedkar Open University. This is a chance.
The chance is
There.
Yeah, there
She
is a
scored.
70%.
This is a score.
70% is the
Now we
deadline
have to
actually.
estimate. This is a deadline. So
Yes, sir.
she is getting the she got the better score. Better score.
Yeah.
Now she is able to join in this institution.
yes.
Yeah, that is one of the application problem. Similarly, I can explain one more example problem for better understanding the this area property. For a certain types of computers, the length time of between charges of battery is normally distributed with a mean of 50 hours and standard deviation of 15 hours. Mahalakshmi owns one of these computers and wants to know the probability that the length time will be between 50 hours and 70 hours.
Yes.
She is expected.
Yes.
How much chance if she buy a computer? Okay. So now same thing. Let x be a which type of continuous random variable only this is. Let x be a random variable that represents length time. Okay. The length time. So the length time of the distribution is normally distributed. So therefore my x follows what? Normal distribution n of mu comma sigma.
square.
So mean value is already given to us 50 and standard deviation is also given to us, that is 15. The standard normal variate formula already we know that. What is the standard normal variate? Z is equal to x minus mu by sigma. So now which value we need to find here? So we have to find probability of x lies between, what is the value? 50 to 70. So therefore my probability values, probability of 50 is less than x is less than 50 is equal to, then these values are transformed into z value.
Convert into Z.
Convert into z. When x is equal to 50, my lower limit value is what? 50. My maximum value is what? Upper limit value is 70. So when z is equal to 50, then z is equal to 50, my formula is this one. 50 minus 50 by 15, that's 0. Something by 0 is something by 0 by something is always 0. So that I can say Z1 is equal to 0, I can say. When x is equal to 70, my z value is 1.33.
Yes.
So my x values are transformed in terms of Z1 and Z2. Therefore, probability of 50 less than x less than 70 is equal to probability of Z1 is less than Z less than 72. So what is your value? Z1 is 0 and so Z lies between 0 to 1.33. So the total area under this 0 to 1.33 curve value is 0. From table, already I shown the table, now to identify this table value. Okay, that is 0.9082.
So that should be converted into probability of Z is less than
Yes.
Z2.
Yes.
So if it is Z1 is less than Z is less than Z2,
Yes.
we are supposed to convert into the Z is less than Z1 and Z is less than Z2, like
Z2.
that we are supposed
Yes,
to
sir.
convert.
Yes,
and
sir.
then
What,
we
sir?
can go for
Yes,
the
yes, sir. So
tables.
my value is according to our question is, what is the chance here? Chance is there. How much chance is there? That is 0.908, as closer to 1. Yes. So the probability that Mahalakshmi computers has a length of time between 50 and 70 hours is equal to 0.9.
So 90%
90% chance is there.
Yes.
So 90% chance.
is
So one more important application is, sometimes already converted value is given to us.
right. Okay.
Yes.
So two cases, sometimes we need to convert the data into standard form, otherwise sometimes standard form values are given to us. In that case, how to identify the area?
Right.
Yeah.
But
So this is
earlier
the
I said
second
that like that
application.
we are
Yeah,
supposed
this
to
is second application.
Yes.
What is the second application here? Standard normal variate application problems.
Yes.
Okay. If Z is a standard normal variate, find the probability. What is the first one? To the left of Z is equal to minus 1.78. To the left of Z is equal to minus 1.48. Students may be confused with this minus symbol
negative values.
many number of times.
Right.
So I clearly explained with using the diagrammatic representation in that case also.
That is symmetric distribution.
Yeah,
Whatever area minus into 0, this also equal 0 to infinite.
Yes.
0.5 to 0.5.
Yeah. In that case, I
area
will give
should
the
be
one
same,
more area. So that is why we can. This is the one different case.
Yes, sir.
Okay. If I explain like this, maybe a student maybe understand the concept. That is why I can
maximum
choose this.
students are confused
Yeah,
with this.
confused in that case. That is why I can choose this problem.
Yes. Right.
Okay. So I'll explain this problem one by one. Yeah. So to the left of Z. To the left of Z means what? Probability of Z is less than minus 1.78. So my minus means our interval start. What is the range of the Z here?
Minus
Minus infinity. Probability range is also the normal distribution range is start with minus infinity to plus infinity. So I know the end limit.
Right.
So my starting limit is minus infinity. So minus infinity minus 1.782 pi of Z into dz.
Yes.
Okay, this I can write here, split into area symmetric properties. Make use the symmetric property. I can split into two values because minus infinity 0. I know the value because probability divided into the area divided into two parts.
And one more thing, what is pi Z? It is a standard normal variable.
Yes, exactly.
Because here is a new notation.
Yeah.
So that's why we can say that is pi Z is a standard normal.
Standard normal variant. So that is why if both problems are taking the same notation,
Yes.
student may be confused.
Yes,
In that case, I am taking the different notations here. So standardly we are in the textbook also we use this notations most probably.
Right.
Okay. So pi z is minus into 0 is the limit. Then minus. So minus of what is the variable? Minus 1 to 0.
Right.
So total area, this to this one, subtracting this value, then I will get the total value. So left to the Z.
Here
Okay.
minus infinity to 0 means 0.5.
0.5.
Right.
So 0.5 minus this value.
This value,
This part value.
This part
So then we'll get how much area occupied by the left of the Z.
Yes.
That is a one case.
Even
Okay.
minus 1.780 to converted to 0 to 1.78.
Yes.
That area
So
is
next-
available
next-
only positive.
Yeah. Why we can consider that means next I will explain that one only. What Dr. Ramesh is asking this question here, I will explain the next step because I convert that like this only.
Right.
Yes.
Okay. So here 0.5 we know the total area.
Yes.
So here minus 1.2 by symmetry this we can change 0 to 1.78 also.
Yes.
Okay. So I apply the symmetric property only, but from table 0.5 minus 0.4625
Yes.
is equal to 0.0. This is the area.
Right. Yes.
This area we need to up to this one is 0 to
Minus infinity to 0.
minus infinity to 0 is this value.
0.5.
Yeah,
0. I will find out this value already 0.5 minus 0 to here 0 to this value. If we subtract total area, then this shaded area becomes left to the Z part.
Z. Yes.
So what is the Z part here? 0.03. It's a very small part here.
Right.
So this is the one example. First question. If I ask the second question, to the right, one is earlier, one is left. If they are asking the right,
Z
in
greater
that case, Z is equal to what is the Z value? Z is equal to probability of Z is greater than minus 1.45.
Right.
Okay. So already standard form. So now I can calculate my integral values are what? Lower limit. My lower limit value is minus 1.45 to minus 1.45 to infinity.
Positive, right.
Positive. So in that case, what I am doing, same argument I can apply here. Earlier I can subtract, but can adding total value, because I can show in in curve, normal curve. Okay. So my first I can split into two limits here. According to Riemann integral property, we can split into n number of times. So two continuous limits we can consider. In that case, minus 1.45 to 0 is the first limit, plus
the 0 to remaining.
0 to remaining phi of z. So we know that 0 to infinity value.
That is 0.5.
0.5. Right. Okay, na. So then you can check this.
Again, you apply the
I can apply the symmetry. Earlier it is a minus is a denominator. So denominator value is converted to numerator also. According we have the symmetric property. By applying the symmetric property, 0 to my integral value is 0 to 1.45 pi of z into dz plus 0.5 by making use of symmetric property. And so my total value is 0.4265 table plus 0.5. Adding this total, so here to my value I would like to calculate here to here.
Okay.
Total shaded area. This is a shaded area.
Right. And one more thing here, we can calculate very simply. If P is Z is greater than some value, we can simply write 1 minus Z is less than that particular value.
Okay, sir. So that is also one of the option. That is the option. Already students learn the able to know. Already they know symmetric property. That is why we can absolute of explain these things.
So now it is interaction of question and answers.
Yes.
Hello, good evening. Hello, Dr. B.R. Ambedkar Open City. Tell me, ma. If any doubt, today's class is going on.
I'm the student of B.R. Ambedkar Open University. I want to doubt.
Yeah, tell me, madam.
What is the mean and variance of the distribution?
Okay. So I'll explain the mean and the normal. So normal distribution. Okay. So normal distribution. Okay. Mean of the normal distribution is mu. Very beginning we say mean of the normal distribution is mu and standard variance is equal to sigma square. Okay, so then already we either use the moment generating function, or else we can use the another methods. We can calculate we should find the area and mean and variance of the distribution. So our mean of the normal distribution is mu and variance of the distribution is sigma square.
These are nothing but parameters of the normal distribution.
Parameters.
Whatever.
So that is why a student is need to understand and able to always we can remember these two parameters.
These are nothing but statistical measures. Measures center tendency and dispersion. The mean
that
is
why,
mu.
So she is asking very good question, because always we are try to remember these things. Very beginning I given one note also. A student is remember these two parameters.
Yes, sir.
So mean and variance is play the vital role. Very good question.
Yes. So now let us continue another problem.
I'll continue this. Okay, after that we get how much percentage here? 0.9265.
Right. 93% about
93. So almost 92% is chance to get this value. Okay. So another approximations are, this is very important here.
So this is one of the most application of normal distribution.
Yes.
Whenever size n is very large value.
In that case, a student is confused how to identify these things.
Yes.
That is why we are very beginning I given the two important tasks. What is the important topics here? One is limiting cases.
Yes.
So what limiting cases? Two limiting cases. What is the limiting cases? First one is binomial. Another one is Poisson. So limiting case of normal distribution.
These two distributions are discrete distributions. The sample size is very high. Generally, we can assume that follows the normal distribution. How we can assume that follows the normal distribution? Just you can explain.
Yes, sir. So there are normal approximation to the binomial distribution application. Here I am going to explain one example here. So applications of limiting case of the binomial distribution applications. Okay. So first one is there are 100 true or false questions.
Yes.
Generally what is earlier very beginning Sampah sir explained one is application part here. Generally we have to normalize. So sometimes we are getting the set wise examination test.
Right.
So we need to normalize the data. In that case also we apply this normal distribution techniques.
Yes.
So set of people, for example group 1, group 2, group 1 is exam is conducted.
For different session, different
sets.
question papers are
If
there.
people are getting the first set number 1, set number
Yes.
2, set number 3, set number 4.
Yes.
Standard of the question paper is different,
Different.
for each
Different for
session.
Even the scores should be percentage converted to only by using normalization.
That is called as a normalization. We can apply some normalization
Percentile.
factors.
Yes.
Okay. So here also we can apply some normalization. So that means we have to use some correct measurement. We can take some correction factors here
Yes.
to convert the data into this appropriate model.
For
So in
converting
that,
this, the sample size should be the very high. At the same time, probability should be very small.
Very small.
So this is the basic fundamental principle for converting discrete distributions to the normal distribution.
yes.
Yes,
So in that example, I like going to explain one example in that case also. There are 100 true or false questions. What is the probability that guesswork will be yield? So students are behave that sometimes chance, I'll choose this one. What is the chance of getting that marks, scoring the marks? So in that case, first by exactly 45 correct answers out of 100.
Yes.
So second bit is I am asking 45 to 55 correct answers, both inclusive, means including 45 also, including 55 also. In that case we are taking less than or equal.
Less than or equal.
Okay. Less than 40 correct answers, chance.
Yes.
So here number of 100, that means number is big number. Okay, let x be a number of correct answers. It's a random variable. My random variable is number of correct answers. Since x follows here, chance means equal chance. P is equal to 1 by 2, Q is equal to 1 by 2. Guessing only. Equal chance.
Yes.
Okay, guessing means either it may be correct, either it may be wrong. Chance is what is the chance? 1 by 2.
There is no link between those things, so we can say discrete first.
Discrete function. This is a discrete function.
Yes.
Now it's a discrete function. The discrete function we should convert it into continuous.
Continuous.
Because sample size is very high.
Very high. In that case, let x be a random variable of correct answers since x follows binomial distribution. So binomial distribution n comma p. N is a number of trials,
Number of
and
sample.
p is a probability of
Success.
success. Okay. Here that is generally we know that p is known as a mean. Okay, n comma
NP.
Mean of the binomial distribution is np. Okay, in that case b of n comma 100 comma 1 by 2.
Yes.
Therefore my mean of the binomial distribution is equal to expectation of x is equal to np.
Yes.
Okay, now I can substitute my n value is 100 and I can substitute these values in this function, in this equation I get
50.
mean value. My mean value mu is equal to 50.
50.
50.
Yes.
So then variance, already we know the variance of the binomial distribution. What is the variance of the binomial distribution?
We know NPQ. Okay.
So NPQ is equal to 100 into n is 100 and PQ are having the same chance.
Yes.
That means 1 by 2 into 1 by 2.
Yes.
So I can simplify this 25 variance. So now I get the standard deviation. I want to standard deviation. How to get the standard deviation? Square root of variance. So square root of 25 is equal to sigma. Sigma is equal to 5.
5.
So my first question is probability that guesswork will be yield exactly 45 correct answers is.
Yes.
What is that? Exact means what? Equal.
X equal to 45.
X equal to 45.
Probability of X
So
equal to
probability of X is equal to 45. Then I can go for correction factor because this is this interval is I can convert it into continuous factors.
Okay, right.
So what is the reason how to convert? What is the purpose
Because
of
it
this?
is earlier one is discrete.
Yeah.
Now it is a correction is what is that case? Limiting case. Which limiting case we can consider here? Binomial distribution. Okay, binomial case is in that case that data is converted into continuous factor.
System.
They can adding 1 by 2 0 point correction factor 0.5 is adding in lower limit, subtracting lower limit and adding from the upper limit.
Yes. Yes.
Yeah, here my lower value is 45 minus 0.5. This is a correction factor.
Okay.
Yes.
By making use of this equation is converted into continuous manner. Okay, less than or equal to x is less than or equal to 45 plus 0.5. Okay,
Yes.
My values are where earlier it is what is the line? X lies between where to where? 44.5 to 45.5. So now standard these data I can convert into standard normal
Standardization.
yes, general
Yes,
procedure.
yes,
What is
yes.
that? 44.5 minus my mean value is what?
Mu value is 50 by standard deviation. Is less than or equal to z is less than or equal to 44.5 minus same. Okay, then my normal values are like by making use of table I got this value. Very less chance to expecting that answer. Very less value, that is 0.0483.
Yes.
Okay. probability that guesswork will be yield 45 to 55 correct answers, both inclusive. Inclusive means we can adding less than or equal to.
Yes.
Okay. So again we can adding the correction factor. What is our correction factor here? 45.0.5. So now 45 minus 0.5 is less than or equal to x is less than or equal to 55 plus 0.5.
Yes.
Then after simplifying these two, we will get this one. What is that? Probability of 44.5 is less than or equal to x is less than or equal to 55.5.
Now again convert into Z scale.
Again convert into Z.
scale.
So after getting the Z, I will get these values.
Yes.
What is the value? The range of the distribution is like this. Okay. So then we will get, what is the chance here? Chance is 72%.
Right.
If the student will get appropriate answer, the chance, probability of that guesswork will be yield 45 to 55 correct answers, both inclusive, is 0.7286%.
Right. 72.86.
Yeah, 72 point. If we convert it into percentage, it becomes 72.86. Okay. Another one is, one more question is asking here. One more bit. Probability that the guesswork will be yield less than 40 correct answers.
Right.
So in that case, what is that probability? Probability of x less than 40. X less than 40. Probability of z is, so after converting the standard normal variate, this is, that value is already correction. I use the correction factor. Then it becomes what? 40 minus 45. Then minus this one is equal to
Z less than
z
minus
less than
2.8.
minus 2.38.
Yeah. Again convert into
Again
symmetric
converted, we
property.
can use the symmetric property and I'll get this value, that is 0.0087. Okay, very less value.
Yes.
Okay, so this is the few examples which is related to this application area related problems. One is a normal curve related problem, variate problems, and Z is given to us. Sometimes that guessing questions are limiting case problems. So this is the today's sessions here.
Yeah.
So now I am asking any doubts, any queries, any doubts will Dr. Ramesh, you can ask any doubts regarding
can
any
ask
questions. We will clarify the doubts for the student
You can
questioning.
give phone number.
Yeah. So any doubts, students? So today's class. So please call 040-23680-456. Yeah. So thank you, professors, for giving wonderful session. I think this is a very important topic in BSc 4th semester UG students, statistics. One of the most important normal distribution is applicable in many cases, even probability, data science. So please. Hello.
Good afternoon, sir.
Good afternoon, sir.
Sir.
Yeah. Tell me your.
Sir.
Any doubt in this today's class?
What is the movement generative function of normal distribution, sir, and how we obtain the movement by doing it?
Yeah. How to get a moment generative function? Yeah. So 1 minute, so please.
Yeah, actually using moment generating function, we can simply, we will get the moments like we can take the differentiation of the moment generating function, first differentiation and t equal to 0, we will get the mean value, and if we take the second differentiation, we will get the mu2 prime, and based on the mu2 prime, we can get the mu2 equal to mu2 prime minus mu1 prime square. We will get the value as sigma square as a standard deviation.
Yeah. Mu is nothing but central
So
moment.
actually student is get the doubt is generating function. A student can remember this, mx of t is equal to
E power mu
to the
t.
power of mu t plus half into sigma square into t square. If you do the differentiation with respect.
Yeah. So 1 minute. Sir. Hello, Dr. Ambedkar University. So today's class, any doubt, please?
Hello.
Yeah, tell me, sir.
Sir, what is the movement generative function of normal distribution?
Yeah.
Same question already just okay.
Okay. Please listen. Okay. Yeah.
Okay.
Same question again. Previous Dr. Sampah sir explained again. Once again, I am explained that about what is the moment generating function of the normal distribution. Okay. Generally, moment generating function we can take mxt, mx of it's a representation.
Yes.
How to represent the moment generating mx of t is equal to e to the power of mu t plus of sigma square into t square. So this is the moment generating function of the normal distribution. If we differentiate with respect to t and puts and substituting t is equal to 0, we'll get first order moment.
Mu 1 dash.
Again, if you repeatedly do second order, if you do the second order, then we'll get the second. I hope you are understanding this moment generating function condition and definition.
Yeah. So
Thank you for
Thank you.
thank you, professors. So your presence has made this teleconference meaningful and successful. Thank you one and all once again.
Thank you.
Thank you.
Wonderful.
Welcome to T-Sites.